Hello, student. Let's try to understand today the chemical properties of phenol, student. There are the more than 10 chemical properties are there, which are important, student, that we have to understand. The first one, if you talk about student, that is reaction with metal, student. Reaction with active metal. We are studying that is active metal. Whatever the active metals are there, that is with which, how it going to react, student. So suppose if you are taking the phenol, student, here is the phenol. This is the phenol. And you are treating with the sodium metal, student. So what is it going to give, student? It is going to give the sodium phenoxide, ONA, and plus it will release that is half mole of hydrogen gas. Since the reaction is giving the hydrogen gas and the salt, student, the reaction is telling that phenol is what? The acidic in nature. Second one is there, reaction with base, student. Reaction with NaOH. So you see, student, how it is going to react, student. So here you see, here, this is what is, student. This is the OH is there, dear student. And here is that is we are having NaOH. So what it is going to happen, student, this is going to form the, again, sodium phenoxide, student, ONA, plus it will give the H2O. This is what is that is neutralization reaction, student, neutralization. And this reaction also explains, student, neutralization reaction, that the phenol is acidic in nature, right? Next one reaction with we are going to the study, student, that is esterification. Esterification. Now, when you are treating with the ester, student, okay, acid anhydride, so it is going to give student phenyl acetate. Let us see how the reaction is going to happen, student. This is what OH. And you are treating with the phenyl acetate, CH3, C double bond O. Here is again O, student. This is C double bond O, and here is CH3. So how the reaction can proceed, student? This is the carboxylic acid will be out, student, in this form. So here is the CH3, C double OH. And what is there, student? What is the other things which are left over? This is the benzene ring. Here is O. This is C double bond O, and this is CH3. This is what is called, student, that is called phenyl acetate, student, ACETAT, phenyl acetate. Now, the one more reaction we can proceed, student. Here is what is there. O and H is there, OH. And here we are doing, a student, what is the CH3, C double bond O, and here is Cl. So this is what, student, here is again, this is going to be lost, student. This is HCl is going to be lost. And what the product you are going to get, student, that is the same product you are going to get. Phenyl acetate O, this is CO, CH3, student, plus it will release the HCl. Now, one more reaction is possible in the, that is phenyl acetate can be obtained in another way, student, also. You can treat with the acetic acid, student, CH3, C double bond O, and here is OH, student. So what you can do is, student, here the reaction can take place like that. So here is the H2O is being out, student. And what is the left here, dear student? What is left here? See, here will be the O. And here is what, student? COCH3. This is again going to be what, student? That is phenyl acetate. Acetate. This is the what second. Now let us try to understand, student. That is the with the nitric acid, student. So nitration, we are going to study nitration of phenol, student. Nitration of phenol. So nitration of phenol takes place in two different ways, student. Let me say that is what is, this is the phenol, right? Here is the what is there, OH. Okay. Now, if you are taking the dilute HNO3, right? So dilute HNO3, that is substituted, the phenol is going to be obtained. Here is OH, student. It can be NO2. This is the one product. And another is there, student, what we are having. That is OH is there, and this is the NO2. So mixture of product it will give, student. That is called para-nitrophenol. This is the para-nitrophenol, student. And this is what is called orthonitrophenol, student. Orthonitrophenol. Now, next one you are treating with the concentrated HNO3. So it will give tri-substituted student. Tri-substituted product means nitro group is going to be at 3 position. Here is OH student. This is the NO2 group student. Here you can find that is again NO2. And this side you will find that is again NO2. So it is what student? 2, 4, 6. This will be what student? Trinitrophenol. So here, if you are treating with the concentrated nitric acid student, it will give the nitrate ion, that is the electrophile large in quantity. So it will give the trinitrophenol. But if you are taking dilute, it will give the monosubstituted ortho and para nitrophenol, that will be in the form of mixture. Next one, student, that is bromination. Bromination. So bromination is also two types, student. Right? Bromination is also two types. If you see, this is the phenol student. Here will be the OH group. And bromination can be achieved in two different ways, dear student. What are the two different ways? You can take the Br2 in CS2. You know, student, it is the CS2 is non-polar solvent. So it formed the, that is electrophile, very smaller in quantity. So it will give mono-substituted student. So here is the Br, okay. And plus it will again give student, that is here is the OH is there student and downside Br. So this is orthobromophenol. Orthobromophenol. This is student, orthobromophenol is the minor student. This is the minor. And that is parabromophenol. This is the parabromophenol. And what this parabromophenol is, that is the major student, right? Here student, if you treat with the Br2 in water student, you take the Br2 in water. So what you will get student, that is the water is polar solvent. So it will form the electrophile much more student. So it will give the tri-substituted student, tribromophenol. So here the product is what student? 2, 4, 6. It will be what student? Tribromophenol. This is what is the going to be what student? Product. You can see here 1, 2, this is 3, 4, 5, 6, 2, 4, 6 tribromophenol. Next student, also you can see in the next reaction, what you are going to find here, we are treating with the sodium dichromate student. So here we are having, if you see this reaction, what you are going to find here, that is the, this is the phenol group, right? So next one, you are treating with the oxidizing agent. What the oxidizing agent you can take, student? K2Cr2O7. This is the K2Cr2O7. So what the product you are going to receive here? This is the, here it cannot be the circle student. And it will give the O group is here and O group is here. Okay. This compound is called student benzoquinone student. Benzoquinone. This is benzoquinone. Now, this reaction is called student oxidation. Oxidation of phenol. So if you are going to oxidation of phenol student, it is going to give benzoquinone student. Next one, the reduction of phenol student. You can just study the reduction of phenol, right? Till now, major reaction we did not study student. We are going to, it will take 5-10 minutes more. Here you see student, this is the phenol, OH. And you have to treat with the what student? Zinc dust. So if you are treating with the zinc dust student, what is going to be there student? This zinc will be out student. Okay. Zinc plus oxygen, this is going to be ZnO student. Right. And what it will going to give student? This is going to give the benzene. Here is hydrogen is there. Hydrogen is actually every corner student. So you can simply represent this is the benzene student. This is the benzene. Okay. Both are the benzene only. Now, after the benzene student, we are going to treat with the Riemann-Tiemann reaction with chloroform student, with chloroform, okay, chloroform and sodium hydroxide. Student, if you are treating with this one with chloroform and sodium hydroxide, that is called student Riemann-Tiemann reaction. Riemann, T-I-E-T-M-A-N-N, Riemann-Tiemann reaction. Right, student? This is what is called Riemann-Tiemann reaction. Now, student, what they are saying, here we are seeing this C. This is the, what is the case of the OH, phenol. Now, if you are treating this one, student, CH3Cl, this is what is called chloroform, student, chloroform. So, CHCl3 plus NaOH. So directly it will give the salicylaldehyde student. This is. So here is the OH student. This is the OH group. And next one we are having what here you will find that is the CHO is going to be attached. Right. So this compound is called student salicylaldehyde. No, SALI, salicylaldehyde. Right. So this is what the product. Now, this reaction can also be in the many steps, student. That can happen in the many steps. Okay, not in the single step. So what we are going to do here, this reaction, this is what is the OH is there, student. And now, first of all, you treat with the NaOH, student. So when you are treating with the NaOH, it will become the reactive, student, and it will give the ONA. Now, what are there? Here is the hydrogen is also there. You treat with the CHCl3. Right, student? So minus it will be the HCl will be out, student. What the product you are going to receive here? So here is the intermediate you will find, student. This is the CH and this is group is what is Cl and Cl. Again, you treat with the 2 NaOH, student. When you are treating with the 2 NaOH, so 2 NaCl is going to be out, student. Minus 2 NaCl. So here you see the product you see, student. What can be the product? Here is the ONA and here is student CH. This will be that is OH and here is OH. Now, student, what we are going to do, student, here you see this is the OH and here is H, student. So minus it is going to be water molecule, right? So here you see the here is the ONA and here is what is there, student? CHO. Here just you hydrolyze, acidified, student, with the HCl. So that is minus it will be NaCl. NaCl will be out, student. How the NaCl will be out, student? Here see the Na group is there, Na group, and here is Cl. Okay. So what the product is going to be? What the product is going to be, student? So here you see, student, this is the OH and here is what is this, student? CHO, salicylaldehyde, salicylaldehyde, CYLDEHYD, salicylaldehyde. This is what the product, right, student? So this is what is called the Riemann-Tiemann reaction, student. Now the another reaction is there, Kolbe reaction, KOLBEYS, Kolbe's reaction, student. How can you do the Kolbe's reaction, dear student? Very simple reaction, student. With CO2, student. With CO2. We are doing the CO2 and NaOH, student. So here you see, student, what you can do here. There is you can do in the single step, student. That is CO2 plus NaOH. So it will give the student salicylic acid. This will give student what? Salicylic acid. OH and C double OH. Salicylic acid. CYLIC, salicylic acid. Dear student, this reaction can be in the 2 steps also. So how can you do, student? Here is the OH group. Just you treat with the NaOH, student. NaOH. Here, what you are going to receive, student? This is the ONA. Now you treat with the CO2, student. So once you are treating with the CO2, so what is going to happen here is ONA is as it is there, student. This the C double OH. Now acidified with H plus, student. Acid, any HCl you can take, student. So it will give the OH, student, and here is C double OH, salicylic acid. So this is what the reaction what we studied, student. Many reaction we have studied. If you see, I hope I covered all the reaction. Let us go back and see. The first reaction we study, student, what is that is called reaction with sodium metal. Then we study the NaOH. So in both cases, these two reaction explained that is phenol is acidic in nature, student. As the acid react with sodium metal give the salt and hydrogen gas. So here it is also giving the sodium phenoxide salt, student, and that is hydrogen gas. So the salt and hydrogen gas, that is going to be the phenol is acidic. Same neutralization reaction, student, acid base reaction, salt plus water. Next reaction you see, student, we have to study the esterification reaction, student, with the acetic anhydride, acid chloride or the acetic acid. All cases they are going to give student ester, and that is the phenyl acetate. Sweet fruity smell is going to come, student. Next one, nitration, student. Nitration can be done in the 2 ways, student. What are the 2 ways of doing nitration? Dilute nitric acid That is ortho substituted student. Ortho nitrophenol and para nitrophenol give the mixture. Concentrated nitro acid, that is 2,4,6 trinitrophenol student. That is also called picric acid student. Picric acid. It is a strong acid that is also called picric acid. Now let us move the next point student. What is the bromination is there is dear student. If you talk about the bromination friend, so bromination here non-polar solvent is there, so it will give mono substituted orthobromophenol and parabromophenol, and bromine in water it will give student 2,4,6 tribromophenol student. Next one is there oxidation of phenol. So if you are treating with the oxidizing agent K2Cr2O7, it will give benzoquinone student. And if you are reducing with the zinc metal student, zinc done, it will give the benzene student. Next reaction you see student with the chloroform and NaOH. This is the very important student. If you are treating with the chloroform and NaOH, it will give the salicylaldehyde, dear student. Here you can see phenol treated with the phenol. It is going to give the here intermediate. So then it will give salicylaldehyde. Next one is Kolbe reaction. It is also held in many steps student, or you can write in the single step also. So firstly, you are treating with the base, it will give the sodium phenoxide. Then you treat with the CO2, it will give the intermediate. Then on hydrolysis, it will give the product. So this is all about the reaction of the phenol student. Thank you very much for watching, dear student.